Okay, so hi and welcome. Can you hear me?
Yes, perfect.
Okay, so hope all are you well. So basically today is our sixth number of class, and today we will try to discuss about that land use land cover classification. How we can easily do for that land use land cover classification using the different types of machine learning method. We try to discuss about that from beginners to advanced level. We try to discuss all of those machine learning algorithms such as random forest, then classification and regression trees, then support vector machine, and other types of machine learning algorithm. How we can use and then make the land use land cover classification map. After that, we also try to discuss about that how we can easily calculate it, the area, how much build up area, how much vegetation, how much cropland, how much settlement is available for this area. So this type of calculation we also try to discuss. And finally, we also try to discuss about the accuracy assessment. How we can easily make the accuracy assessment using this platform, and also make the what is the accuracy, producer accuracy, consumer accuracy, kappa accuracy. So all of those things we try to complete it from beginners to advanced level one by one. So I hope you can easily learn all of the things. Okay. So let's go. So I simply share my screen. Okay, so now can you see my screen? Okay, good.
Yes, perfect.
Okay, so let's. Okay, so basically today is our sixth number of class, and today I will try to discuss about that how we can easily make the land use land cover classification using the machine learning, and how to make the land use land cover classification chart, then calculating land use land cover classification area, and finally how to add the legend on your map. Okay, as well as we also try to discuss about that how we can easily check the accuracy assessment of this land use land cover classification using the kappa, as well as also overall accuracy and producer accuracy, consumer accuracy. So all of those details we try to calculate it in this online training program. So let's go. So first of all, when you want to make the land use land cover classification map using Google Earth Engine platform, we have to follow some step or process. And this process is the same for any kind of land use land cover classification map. First of all, you have to selecting your region of interest. Which area you want to make the land use land cover classification map? Just simply select this area. This is your ROI. If you want, you can import the boundary shape file, or if you want, you can import the polygon. Anything is as your region of interest. After that, you have to choose and filtering the image collection. If you want, you can use the Landsat image, or if you want, you can use the Sentinel imagery. Okay, you can simply choose and then filter this image collection according to the your region of interest, according to the specific time period, according to the specific metadata. Okay, all of those filtering you apply. After that, you need to collect the training point. You can take the training point for water body, you can take the training point for vegetation, you can take the training point for build up area, you can take the training point for cropland. All of those classes which you want to classify, just simply take the training point from these satellite images. After that, you need to merge all of those training points together. Okay, so all of those training point you can simply merge and store it in a one variable. After that, you need to make the training data set. So mainly this training data set created by the pixel value, band pixel value. So it extract the band pixel value and create the training data set. This data set we need to divide into two ways. Some data set we are using for train our model, and some data set we are using for testing our model. Okay, so this data should be divided. After that, we need to create the classifier. This classifier can be support vector machine, as well as also random forest. It can be classification, region, place, any kind of classifier we create and classify the image, as well as also create the classified image and display the result. Okay, as well also print the confusion matrix for accuracy assessment, as well as also calculated the area for each classes. Okay, so let's go. I try to show you the practical example about this land use land cover classification map, so then it's also better. So for that, I simply open my code editor and try to show you this part. So let's go. So just I open the code editor. And then open this code editor. Okay, so it opened. So in this time, first of all, I can simply search here. Suppose my region of interest is that. Suppose I want to work for the Boro Pupuria. Just a minute, I simply find out the region. What is the name about that? Okay, simply search. Okay, so basically I want to work with this region. Okay, just a minute. I take the phone and then continue. Just a minute. Okay, so let's go. So this is my region. I want to work with for this in this time. I simply search this region in here. Okay, can you hear me now? Hello. Hello, can you hear me? Okay, okay. I think some networking
Yes.
issue. Okay, so now continue. Yeah. So just I simply search here my region of interest, which is in work. So you can see I simply go to this region. Suppose this is my study area. This is my study area. So in this time, if you want, you can simply import your boundary shape file from the asset tab. Or if you want, you can simply draw this region of interest. Suppose I simply draw this region of interest. Suppose this is my region of interest. I simply drag and this is my region of interest. I need this map for this region. Okay. So I simply draw this region of interest look like this. About that, Boropupuria coal mining region. So basically this is the coal mining region. So I simply draw. Okay. So now I select my region of interest. So this is my region of interest. In this time for this region, I want to create the land use land cover classification map. I simply put this name such as ROI. Okay, you can easily name. Okay, so after that,
I can. Wait.
okay, so okay, so let's see. I think yeah. Okay, so now can you hear me? Yeah, it's great. Yeah. Okay, good. Thank you. Okay. Okay.
Yes.
Okay. So just I simply this is my region of interest. I put the name ROI. So this is my first step I done. So now I want to choose and filter in the satellite image collection. So I draw.
You,
I
you
write a
haven't
comment. Choose.
you you haven't shared the screen.
Image collection. Okay. Choose and filtering image collection. So okay, so in this time I want to work with for the Sentinel-2 satellite imagery. So for that I simply go to the Sentinel-2 satellite imagery. Oh, sorry. Okay, so let's go. Okay. Okay, so I import this about this my region. I simply draw the polygon about my region, and then I need to choose and filtering the image collection. I simply open my data catalog and go to the Sentinel-2 image collection. So here I use this Sentinel-2 satellite image. You can see the Sentinel-2 multi-spectral instrument. Just a minute. Okay, so I simply work with for that. You can see I simply go to the top surface reflectance image I want to use for the creating the land use land cover classification map. And then I can simply copy this art engine snippet from here and then paste into this code editor. Okay, so now this image collection is imported, and then I simply give a variable name. Suppose I put the variable name is that Sentinel-2. You can use any name, there is no problem. Okay, so after that, this image collection I need to filter. Okay, so for that I simply take a variable, suppose image, and call this Sentinel. Okay, Sentinel-2. I simply copy the variable name and paste here, Sentinel-2, and use here the filter bounds function for intersecting all of those images according to my region of interest. So ROI. Then use here the filter date function. Suppose I want to make this land use land cover classification map for year of 2023, 1st January from year of 2023. Okay, so I take this. Okay, so I put. Okay, I take the time period about the latest time period about that 2023 07 16. So I put this time period in here 07 and then 16. Okay, So in this time, I also use here the filter metadata. So I choose only for those images which image will be not more than 1% cloud cover. Okay, which will be not more than 1% cloud cover. So use here filter metadata, and I simply go to this image properties. You can see the image properties. Just simply copy the cloud pixel percentage. I select here the less than 1% cloud pixel percentage. So use here this less than 1. Okay. So after that, I want to check how many images is available for this region. So print image and use here the size function. Okay, so now you can see the 21 images I want to got for this region. Okay, so in this time I want to use the total 21 images and make a median composite. So use here the median, and this median we click with my shapefile with ROI. So now display this result. So for that I can simply use here map dot layer and call the image and click to the run. So now one image is added between this time period. We can get this image in here. You can see. Okay. So I want to add the visualization. So I simply use here this. Simply click on here and put here suppose before red, then green, and also blue. And custom 98%, and then apply. Okay, so now I can get this image look like that. You can see. Okay, this time period we can get this image look like this. So now from this image I want to classify the build-up area, water body, then cropland and barren land. Okay, using the random forest classifier. So let's go about that, how we can easily do that for calculating this type of analysis. So for that, okay, so this is our second step for choosing and filtering the image collection. Okay, so now I also imported this. Okay, so I simply import that and then simply copy and then paste after the object name. So now this visualization will be set with my code. Okay, so now click to the run. So now I can get this image look like that. So now from this image I need to get the training point for a specific class. Okay, so for that what can I do? Just I simply go to the below and then simply search here. Suppose I simply take a variable. Okay, before that we need to take the training point. Okay, when you want to take the training point, then we can use the different types of spectral or different types of band combination. Suppose you can see here I use the true color band composite. Okay, so when I use this another band combination such as I use here the near infrared B8, then I put here the red band and then put here this blue band. Okay, custom 98%, and then apply. then I can get the another types of visualization. In this time I can get the visualization look like that. Okay, so in this time when you are using this type of band combination, then water body look like as a black color. Okay, water body look like as a black color when you are using this type of band combination. Okay, so in this time I use this band combination and take the training point for water body. So click to the new layer and then go to the click in here, and then I simply put this name is that suppose water imported feature collection, and property will be, I set the property suppose class, and set the value for the water geo, and then okay. So now I simply select the this type of point. Okay, if you want you can also use the rectangle, but it also better. So just simply select that marker and just take the training point using this way. So just I simply take this training point, you can see for the water body. Okay, water body look like as a black color when I use this type of band combination, and we can easily take this training point as a water body. So I take this training point for the water body because it is a supervised machine learning method. In the supervised machine learning method, we need to define the pre-category of about this data. So I just simply select that and put this. This is the water body for this region. So all of those black pixel value identify the water body. This is the water body. You can see the black color water body, and this is the river. In this region also you can get a small river. Okay, it's also water body. Also you can see this is the water body. Okay, so I simply take this training point as a water body. So after that, I also need to take the training point for another. Suppose in this time I take the training point for settlement or build up area. So for that I use the another band combination for settlement. I use that the red band, then green band and blue band, also custom 98%, and then apply. So now I find out the build-up area. So basically this is the build-up area for this region. We can easily find out the build-up region. So this is the build-up area, you can see. So for that I taking the new training point, I simply click on the new layer and then click on the geometry and put this name as that build-up. Okay, and then import as a new layer feature collection. Property name will be same for class, and set the value for 1. Okay, then okay. So now I take the training point. So this is the build-up area. We can easily take the training point from the build-up area. This is the build-up area. We can get some settlement as well as we can get the Boropukuria coal mining region. You can see. So this is the Boropukuria coal mining region. We can take the training point from here as the build-up area or settlement. As well as we can also find out the build-up area also in here. Okay, this type of I think is a settlement. This is the white pixel value. This type of white pixel value identify the build-up region for this. Okay, and also this is the build-up area. So we can get this in here about the build-up area. Also you can see the build-up area. We take this training point as the build-up area in here. You can also get some build-up area also in here, white pixel. Or you can also get some build-up area as the white pixel value identify the build-up area information. Okay, we take the training point build-up area. So after that, I take the training point for barrel length. Okay, So mainly barren land we are using at this type of band combination. It mainly reflected the short wave infrared one. So short wave infrared one is the B11, and then put here the near infrared B5, and put here this green. Okay. So this band combination mainly used for identify the barren land as well as also cropland. So just I simply use there and then stress 98% and applies. So now you can easily find out the barren land as well as also build up area. So let's check. Okay, so I simply I think it will be B red band, okay, B4. Okay, so you can simply go to your website and get all of those band combination result. So I simply go to this result, band combination of lancet data. I simply search here. So in this link, from this link, we can easily get the idea about the band combination and which band combination provide which color. We can easily find out from here. You can see. So I want to use this band combination 652. Okay, 6 is the short wave infrared one, then near infrared and blue. Okay, so for that I simply click on here, short wave infrared one. I take the band combination band result about that. What is that? So short wave infrared one. You can see the short wave infrared one is that, yeah, short B11. Okay, short wave infrared B11. So just I simply select at the B11. After that, we also need to check about this band near infrared. Near infrared is that B8. Okay, near infrared is the B8 for sentinel. Near infrared will be B8. And blue is the 2, then apply. So now we can get the better result about that. Yeah. So now we can easily find out the barren land. So barren land mainly this type of color identify the barren land region. Okay. So this is the barren land. Okay. So in this time I simply click on here and then put here such as the barren land or fellow land. Barren land is also fellow land. So feature collection, property will be class and set the value for 0, 1, 2. Okay, for the barren land 2. So I put here, you can see 0, then 1, then 2. Okay, so now take the training point about this barren land. So simply take this training point for the barren land. Okay, so I take this training point for the barren land. This is the barren land as the river bank. So this type of barren land we can take this training point as the barren land. The barren land or fallow land, we can take the training point. Okay. So after that, I also classified the cropland. So take the new layer and then use here the cropland or agricultural land. on this Boropukuria coil mining region. Feature collection set the property as a class and put here this 3. Okay, so you can see the sequence 0 1 2 3. So in this time we can easily find out the cropland look like this color. Okay, so this type of is the cropland. Okay, it will be cropland. You can see this type of light green color, it's identify the cropland, and deep green color identify the vegetation. Okay, so you can see this is a cropland. Okay, so I don't interpret, so just I simply click on here and then delete button, then it will be removed. Okay, so this is the cropland. This type of color identify the cropland. Also this type of cropland. Okay, if you want to check it from the satellite image, click on here, and then we can also get the Google satellite imagery from here and also identify the this type of analysis. You can see, yeah, so it opened. So now we can simply, yeah, so this type of region in this time it's showing the barren land, but for in this time period we can get the some cropland area, or we can see the cropland. Okay, cropland. So for this time we are just taking this cropland from here as a agricultural field from here. Okay, so let's go. For that I can simply click the cropland and then click on this marker and select the cropland and take this training point for the cropland. So this is the cropland. 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 And this is the vegetation, all of the things vegetation. So we can give the some cropland in here. Cropland. Get some cropland in here. Okay, so now after the cropland we take the training point for vegetation. Okay, without cropland I take the training point for the vegetation. So use that the vegetation collection property will be class and put here the 0 4. Okay, then okay, so you can see 0 1 2 3 and 4. So there is a lot of vegetation we can easily find out from here. You can see, so this is the vegetation. So this is also vegetation. Also vegetation. This is also vegetation. So now my training point will be done. You can see here I add this all of this training point such as water, build up, barren land, cropland and vegetation. So now all of this training point I need to merge. So for that I need to merging. So merge all of training points together. So for that take a variable, suppose sample, and then I simply merge all of this training point together. So I put here this sample look like that. So I put here water, and it merge with build up, then merge with parallel, then merge with cropland. It also merge with vegetation. Okay, so all of those things I want to just simply merge and give a one variable. Okay, so just simply print that variable sample and click run. So now we can find out this result. You can see how much training point I collect. I collect here total 296 training point from this images. Total 296 training point, and here you can get all of this training point list in here. You can see total 296 training point list. Okay, as well as if you want to check what is this training point, what is that class, you can see this class is that we can get the class for this properties is that 0. Okay, so 0 means that water. So for this training point I use for water. Okay, so all of those training point is the labeled. Okay, their label is connect in here. You can see for the 79 training point is for the class 1. So here I can get all of those things one by one. So here you can see I can get this result in here class 1. It means that showing the result for that it means that it will be one class, so build up area. So it's showing the build up area class, as well as also you can see all of those class training point as a labeled. So this is my third step, which I show already in the group. You can see I simply select my region of interest, then choose the Sentinel-2 satellite image, and filtering this image collection, it also done. I take the training point, okay, it also done. I merge the training point, it also done. So now I just simply make a training data set using the pixel value. Okay, so I need to create this data set using this pixel value, band pixel value. So for that, which band I want to use, so this type of band I need to store it in a variable. Okay, so which band I use, so for that I can simply take a variable, suppose bands, and then make a list. In this time all of those band list I included here. Here you can see, here I can get the band. So I use only for the 10 meter band. Okay, 10 meter, also use at the 20 meter is also okay, there is no problem. So 20 meter band I want to use in here. So for that you can see 10 meter band we can get in here only for the B2, B3, B4, then also B5 is the 20 meter, B6, B7, B8. Okay, and then also use here the B11 and B12. Okay, so I simply write all of those bands. So I put here, go to my code reader and put here that band is that B2 I use, then also use here the B3, then use here the B4, then use here the B5, then use here the B6, use here the B7. Okay, after that B7 we use here the B8 is the near infrared. Yeah, we also use the B8, and after that we are using here this B8. After that we are using here that only for the B11 and B12. So B11, B11 and B12. Okay. So for that I simply select my all of those band. So now all of those band pixel value I want to extract all of those training point. Suppose this training point I extract all of those band pixel value. This training point I extract all of those band pixel value. So all of those training point I extract all of those band values, and basically this is my data set. Okay, so this is my training data set. So for that, what can I do for making the training data set? So basically it's called the band collection, and then we also need to use here this making data set by bands pixel value. So now I simply take a variable, suppose training, and now I simply call my image. So this is my image. You can see I already create this image. It will be stored in this variable image. Simply call this variable name and paste here. After that, use here the select function, and from this image I select all of those bands which I included in here. Okay, paste here. After that I use a function, this function called that sample region. Okay, and put all of this argument one by one. Basically this sample region function help you to collect the training pixel value from the band. So I use here the sample regions and make a dictionary. So curly bracket start and also curly bracket in here. After that I simply make this collection. So collection is that your training sample or training point. All of this training point is stored in this variable sample. So simply copy that and use here. Okay, and then properties. Property will be same for all of this class. You can see when I take the water or build up it, I use the same property class. Okay, property name is the same all time. So for that I use here this properties name is that class. Then scale I simply put here this scale is the 10 meter resolution I use, and then projection only I simply remove that. Okay, so remove that. So now I simply print this training point. So print and then click the run. So in this time it creates the training data set. You can see. In this time it created the training data set. You can see here. So here we can get all of those pixels. You can see it is, suppose you can see the properties, all of those band value. We can get all of those band value in here. Okay, for this training point. Also you can get this all of those training point. You can see all of those band value. Okay, which I select in here. So basically this is my training data set. Okay, so this training data set I want to use in this time. Okay, so this training data set I need to divide into two ways. So this training data set or training data set divided into two ways. One I use for train my model, and another I use for test my model for accuracy. Okay, accuracy. And train my model I use for So here I use here this 80% data for training, and for test data I use here this 20% data for testing. Okay, if you want you can use here the 70 and 30, there is no problem. So now I want to use the ratio 80% and 20% and take a variable, suppose data set. Okay, so I simply copy the training and paste here and use the function random column, and basically I use here this random column function because I use here the 80% data and also take the 20% data randomly. Okay, randomly I select that. Okay, for that I use here the random column. So now all of those data is stored in here. So now from this data set I have to divide. So I take a variable, suppose put the variable name is that train set. I put this here, I store the 80% data, so simply call the data set and use here the filter dot filter less than equal. Okay, just let's take the function about that. So I use their function dot filter dot less than less than put here this random 0.8. Okay, after that take another variable this set and put here data set dot filter art engine filter, then put here the greater than or equals. Okay, greater than equals, put here the random, here the 0.8. Okay, so now it divided the 80% data and 20% data and store it in this variable and also store in this variable. So now I create my data set. So this data set I use here 80% data and 20% data. So now I need to make the model. Okay, so I'll create the model. Use the same color. Suppose you can see this is a vegetation. I want to show the bar column as the green color. Then cropland show as a pink color. Then barrel land show as a yellow color. Then build up show as a red color. And then water body show as a blue color. So for that I simply use the another thing is the colors. And put here this water body as a blue color. After the water body I use a build up as a red color. After the build up I use this barrel land as a yellow color, cropland as a pink color, and finally vegetation as a green color. So now click the run. In this time we can get the same color with our legend. So you can see the result. Yes, same color we can get in here. You can see. So click on here, we can get the chart look like that. So this is the vegetation 5001 square hectare. Also you can see the cropland 1516 hectare. Also you can see the barren land is the 2949 hectare. Then build up 700 hectare. Also water body only for the 112 hectare for this region. Okay, and we can easily download the data as a Excel file, as well also download the image as a PNG file format. Okay, then we can easily add this our research paper or our report, anything we can easily add this type of chart and also add this type of map. And finally, we also need to add the legend. Okay, so you can see there is the no legend in here. So I want to add the legend on this map so that we can easily identify all of those features. Okay, so for the legend here, I already developed the code about the legend. So in this time, I use the same code and try to show you this part. So further, I simply copy the code from here and then paste. From this code, I just simply copy the legend code because legend code is the same for all time. Okay, so it will be start from here, set position of the legend, and then I'll say, okay, yeah, name, yeah. Just simply copy, and then simply I paste here, I paste on here. Just simply paste in here. In this time, I simply change something about that. Suppose I put this, okay, I put this title name is that. Okay, so, okay. Land is done for classification map of, okay. Just I simply put here this, my new region name of, sorry. So just I simply copy and paste here in 2023. I put here this also here. After that, we also need to add here. I remove that is not a. After that, I simply put here. Suppose, yeah, in this time, I put here our name. So, legend name. So, first of all, water body, then build up area, then we are using here the barren land. So, use here this, remove that. So, barren land. After the barren land, we use the crop land. So, put here this crop land. And then use the vegetation, okay. On also need to change the color about the water body. In this time we need to use the hexacolor code, okay. So water body, build up area, same, barren yellow color. So just I simply put here the yellow color hexa code, simply search here yellow color hexa. Just I simply copy the yellow color hexa code and paste here. I want to show the crop length as a pink color, so I simply put at the pink color hexa code. The pink color hexa code, I simply copy. Pink color hexa code, and finally vegetation shows the green color. So put here the green color hexa code. Simply search here. Color hexa code. So simply copy. And paste. Okay. So now in this time you can see total 1, 2, 3, 4, 5 class. Okay. So that's why I need to use here the 5. Okay. How much class? Just simply use here this class number. So now click to the run. We can get the legend also. So we can get the fully completed land use land cover classification map in Google Earth Engine platform. So now you can see we can get the result look like that. It will be added the classification all of this legend. Also this is the title about this map, and also this is my name about the prepared by me. Okay. So now I can easily just take the screenshot and make this map. Okay. And finally, if you want, we can also export this map as a TIFF format and work with the ArcMap software or QGIS software for the making the map layout. Okay, it also possible. But if you want, you can also add the map color region from here. Also, you can easily add that. Okay, so I hope you can easily learn all of the things. Also, you can calculate the area. Okay, we can easily calculate the area using the chart about this in here. So this is the process for creating the land use land cover classification map using the Google Earth Engine platform. Okay, and next further class we also try to discuss about that change detection, how we can easily make that 2-decade change detection and also make the change detection map and also calculate the transition area, how much water body convert into the build-up area, how much vegetation convert into the build-up area, so how much barren land convert into the build-up area. So this type of transition area, how we can easily calculate it in Google Earth Engine platform and also make the change detection map in Google Earth Engine platform. So this type of analysis we try to complete it in our last class. So I hope you can easily learn all of the things. Okay, and after completing our course. Okay. So anyone, if you have any question, you can ask me any question about that or any problem.
Yes, I have some question I have written also in the chat.
Yeah, what is the question you have?
Well, if it is possible to compute the omission and commission error, and then if there is a way to compute the optimal number of training class directly in Google Earth Engine, and finally, if there is a way to compute the optimal number of trees in a random forest algorithm in order to perform any classification with different number of trees or automatically directly in Google Earth Engine, and then have printed into the console the optimal number of trees that we have to set in the classification.
Okay, so you want to classify the individual trees.
Yeah, but it's possible to try to optimize to.
Okay, but for that we also need to use the ground truth data. Okay, if you have the ground truth data, then we are also using the ground truth point. Suppose mainly this point we need when you classify the agriculture land, different agricultural land. Suppose this is the rice, this is the sugar cane, this is the maize. So this type of analysis when you want to do, we just take the training point from the ground. Okay, we can simply take the GPS location and also import this GPS location in our Google Earth Engine platform as a training point. Then extract this pixel value and make this classification. Okay, so that's why when you want to make the individual trees you want to classify or individual cropland you want to classify, then we need to the ground truth point. Okay, or ground truth data about that specific coordinate, latitude and longitude. Then we are using this data as a point shape file in Google Earth Engine platform and extract the band pixel value and make the classification about that. Okay, so it also possible to do that. So I also tried to show you the next class about that, how we can easily use the ground truth data and make the different types of classification, mainly cropland. Suppose rice, sugarcane, maize. So this type of cropland, how we can easily classify it using the ground truth data. Using the same process, you can easily apply and make the also classified the different trees and also classified using the ground truth data. Okay, so next class we will try to complete this part. I hope you can easily learn about that also.
Okay. Yes, thank you.
Okay, so today is no more. I will send you the practice code for the today's session and also send you the recorded video class. You just do for the any region, any normal region, and classify it for the water body, build-up area, vegetation, cropland. Okay, then make this type of map using the ArcMap software. Also calculate the area and also make the accuracy assessment. Okay, so then it also practice for you. And face any problem, then let me know. We also try to discuss about the next class. And mainly next class we will try to discuss about the change detection, as well as also show you that how we can easily make the map using the ground truth data. Okay, ground truth data, GPS location, and also complete the classification for individual trees or individual cropland about that. Okay.
Okay, we can have the lesson this week, or you
Okay, I
prefer
check
to
the
go
time
to the
schedule just a
next?
minute. So
Okay,
after the okay, so 2021, 23. Okay. So okay, we take the class for the 24. Up 24 is okay.
okay,
Okay, 24.
okay, okay. It's perfect. I will sign
Okay.
in my calendar.
Okay, okay, can just check about that. Okay, so inshallah we'll meet at the 24th July.
Okay, and this will be the last one. Yeah.
Yeah, yeah, yeah. And for the change
Perfect.
about that. Okay. But you can also get the
Okay.
lifetime teaching support. There is no problem after completing the teaching. So when you face any problem, then we can also just for joining any meeting, we can easily connect with the meeting and also talk about the problem. Okay, there is no problem.
Okay. Thank you. Thank you so
Okay, thank
much.
you so much. Okay, have a good day. Okay, bye.
You too. Bye.
Okay, bye.